Hey, what's up everybody? Welcome back to another Layer by Layer. This is going to be a new series on milling for CNCs. This is specifically for the Othermill CNC machine. So take a look over here. We'll talk about the Othermill real quick. So this is the Othermill. This tutorial, this series of tutorials is going to be specifically on how to use Autodesk Fusion 360 with the Othermill and the Othermill Pro. So we actually have the Othermill original, and we'll start stocking the Othermill Pro on the Adafruit shop. So right now it's only $29.99 for the Othermill, I guess, basic, and the Othermill Pro is a little bit more pricey because it's much more. It can cut finer details. So if you want to know more details about that, we have some videos on our YouTube channel. Colin also did a video. We did a review, and I'm starting to do Milling Mondays. So every Monday we have a new CNC milling project, or at least we try to do one once a week. So the first thing I want to talk about is how to get the Fusion 360 library. So in Fusion 360, there's an environment called CAM. This is where all the CAM things are. So you can see here all of the tools have changed. So if you go over here to Tool Library, you can see that I already have the tool library. So the tool for a CNC machine is the tool that will do a specific type of job. So there's all sorts of different sizes, all sorts of different types, flat end, 80-degree engraving bits, ball end mills. We'll talk about all those as we sort of learn them, and you can create tools as well. But for this tutorial specifically, we're going to mill this project here. So I figured we'd start with something really easy. So this is a quick little project that we're going to do. It's an iPhone case here. So we're not milling out the iPhone case, but we are milling out this piece here. So this is a acrylic logo of the Pokemon. This is the Pokeball logo. And what it is it's actually, it looks like a dual extruded print, but this is acrylic. That's a pink fluorescent acrylic. It looks really, really nice. It's very, very transparent, very shiny, and it just looks a lot better than a 3D print in my opinion. So in this project, we're basically combining 3D printing and CNC milling. So right now, it's actually just a two-piece thing here. So this is what the 3D print is. It's printed in Ninja Flex, so you can crush it, and it's very flexible. So that's that part. And then the second part is this very rigid piece of acrylic. So this was milled out of a 4x4 inch piece of acrylic that is 2.75 inches thick. And what I've done is I've done a couple of different tool paths here in Fusion 360 to cut this out. So you get this really nice edge. It's really clean, and it's offsetted in a way where it fits perfectly in line with the sort of Pokemon logo cutout here. And it just snaps into place, and then this base here extends beyond the cutout so that it can stay in place. And then when you put the phone in the case, it can't come out, and it's really nice. So that's what we're going to mill out today. Really, really simple project, and I think great use of combining 3D printing and milling. So that's what we got there. Looks really cool. So in Fusion 360, we'll run through the model real quick, and then we'll quickly start doing the milling stuff. So let me hide this real quick. All right. So this is the iPhone case. This is a project that we released not too long ago. You can modify this case if you want. All the dimensions are drawn with sketches, so you can modify it for an iPhone or an Android phone. And here is the actual piece here. So let me go back out into model so I can show you things. All right, so here's the bumper part, just the bumper part. You can see I have it cut out here. And if you wanted to do a different, maybe you want to put your logo or a different logo or your name or something, this right here, we can suppress this here, and that's the cutout there. So so you can take this design and add a different logo or something like that if you want. But this is what I have for this project. And then the Pokemon logo itself is this guy here. So it is just a little piece here that I made with two sketches. This is the first sketch here. It is just a series of circles. So you can see all the radiuses here, 44 for the outer, and the next one is 38, this one's 15, and this one is 10. They're all centric. They're all centered within each other, and then this here is to create that sort of outline, that cut thing, and then I just extruded them out. So one thing that you want to be, that I wanted to make sure, is that the total height of this logo is actually the exact same height of our stock, our acrylic in this case. So you can see here, if I do, let me hide that. If I do, if I click on this one and click on that, you can look down here and it says the distance between them, that's actually 0.7 millimeters thick. And then this part over here, the extrusion of the logo, is actually 2.05 millimeters thick. So the thinking being there is that when you combine these two dimensions, it's actually 2.75 millimeters, which is the total thickness of our acrylic. So it doesn't have to be that. In this case, for acrylic, I wanted it to be the exact same thickness of the acrylic, because if I were to flatten it, if I were to even it out with the milling machine, I would get this frosted look, which wouldn't look transparent. So that's why I want to maintain that transparency. So these parts here are transparent, and then this sort of area here, the sort of pocket, is actually milled out and not so transparent. It's more like frosted look. So you want to kind of have those. You want to think about your properties, like what am I going to get if I cut this certain. If this was cut in mill, if this was milled out of wood, I wouldn't really have that problem, because there's no transparency in wood, right? So there's that. So once you get your sort of your design in a good state where it sort of makes sense with the material that you want to mill, then we can start moving on to the cam tools. So again, to get the tool library for the Othermill and all the Othermill tools, if you go to this website here, the Othermill's website, that's othermachine.co/support. Their very first thing here, all the way at the bottom, says Fusion 360. In addition to our guide for using 360, we also have a library. So I would definitely walk through this guide here. Or actually, that's not a guide. That's more just like the link to download Fusion 360. But here is the actual tool library. These are all the tools that it comes with. And then just read through this. How do I download it? How do I install it? Just work through this guy here. I don't want to do a tutorial on how to install it, because it's already laid out here for you. So I don't want to have to like recreate the wheel or whatever. And there's a version history. So I'm up to date. Apparently, I have 0.03. which has mostly all of the drill bits that are available in Othermills, for the Othermill specifically. So these are all the tools here that it comes with. All right, so back in Fusion 360, once you get it in there, these are your local library. These are all the tools, and they all have speeds. All the speeds we'll talk about in a second here once we start setting up our setup. So for any type of object that you want to mill out, you want to start up with a setup, and a setup is basically the sort of stock material that you're working with. So I'm going to click on the setup button, and by default it just tries to come up with its own like stock that's relative to whatever the model you have in place here. So we need to fix this up. So the first thing I want to do is go to the stock tab here in our setup panel, and I want to change the mode from relative size to a fixed size. This is telling our cam tools that we have a very specific size of material to work with. So I'm going to enter in 4 inches, because this is actually the piece of acrylic that I have. It's 4 by 4 inches. So that's what it is, 4 by 4 inches. And then the Z, on the Z, it's actually the thickness. And I'm going to interplay inches with millimeters here, so it's 2.75 millimeters. So if we click on it here, you can see that's exactly the height of our model itself. So that's our thickness. So this little yellow ghosted out piece is actually representing our acrylic stock. Okay, and then where do you want to actually mill it? I recommend not milling it in the center, but more near the corner. So the origin of a machine of the Othermill is actually on the bottom left. So the bottom left. So we actually want to move that over there. So what we'll do is we'll go to setup, and then we'll click on here where it says, it's already selected actually, stock point. So you see where it says box point. We actually want to click on this little white dot here. So that's the corner, lower left corner, in the top one, not the bottom or the middle, but the top one there. So when we click on that, you'll see that our X and Y looks okay, but our Z is actually pointing down, and that's not right. Since the way I modeled it was like pointing downwards, I actually want to mill it up, or I want to have this positioned up. So I just clicked on that arrow, and now it thinks that now when we add tools, the tool will go down and not be like drilling up at it, because it's just a weird orientation. So just that's one thing to note, is like to understand where to setting up the orientation of your tool properly. So that's what I'm doing here. So this is now pointing up. This is the bottom. This is the bottom of our part. That's where it's going to be laid flat on the bed of our Othermill. And this is Y and this is X. So that's all looking good. But it's still in the center. So I'm going to go back over to stock. And I'm going to click on model position. See where it says center? I'm going to make it go offset from the right side. And then I'm just going to add something like 2 millimeters, 2 mm. And that already is on the wrong area. I'm actually supposed to go on the left side here. So oops. So there you go. So now it's actually offsetted by 2 millimeters onto the left. And then we'll do the same thing with Y here. So change the model position from the center to the Y backside. I think that's going to be the right one. If not, we'll just change it. So 2 millimeters here. Yep, that's wrong. So I'm going to go on Y negative. So that's looking better. So what I'm doing here is so that I don't want to mill it in the middle, because then I'm sort of have this sort of weird weird stock left over. I want to be able to reuse this stock, use the most of your stock, and by doing it, by making us mill just on the corner here, allows us all this extra area of stock to be able to mill. So it's sort of strategic in that way, where I want to save my material. I don't want to just cut in the middle and throw away this stuff. It's sort of wasteful. So this is more like being a little bit more efficient with our material. So we want to get the most out of our material. All right, so that's looking good. That's pretty much all we need to do for the setup. Again, just follow through, making sure that your Z is actually in the correct orientation, because that will bite you if it's not. So that's looking good. Everything is okay here. We don't have to mess with anything else. So I'm just going to hit OK. So that's our setup. So right here. So that's setup. So that's basically our material, our acrylic. I think we can even rename it. Can I rename it? If I can't, maybe. Yeah. So I'll get like acrylic Pokemon logo. Why not? All right. So the next thing I'm going to do is I actually want to mill out this piece here, all of this inner cut area here. So to do that, I'm going to go over here under where it says 2D and then 2D pocket. So 2D pocket, it basically creates a cutout, or in this case a pocket. It says the entry can be selected anywhere on the model and include various plunges and ramp operations. That may not make sense to you or not, but it's all good. So I'm going to click on that, and here is our pocket operation. So the first thing I want to do is I want to go back to this here panel on the right side and click on Tool. So this is where we get to select our tool. So if we scroll all the way down, you can see our local library. These are all the tools that come with the Othermill library. So you really want to think about what tool to pick, right? So these are all the tools. This is kind of small. This is a little bit smaller. This is a little bit thicker. This is a little bit thicker even more, and this is really, really thick. So you'll learn as you come up with projects, you'll learn which tool is good. But in this case, we're going to pick something in the middle between like too thin and too thick, and that happens to be the 132-inch flat end mill. So I'm going to click on that, hit OK, and you can see that this sort of tool here has updated. And now the next thing I'm going to do is there's a bunch of settings. What do they mean, right? You can roll over it, and it'll kind of give you an example of what it means, but as you go, we'll learn it more. So the next page I want to show you is in Othermill's website, Othermachine Co/support/material/acrylic. Each material has a suggested feeds and speeds. So you'll see here, you can just input these numbers in, and it's specific for each tool. I'm going to go with the advanced feeds, and then I'm going to use these numbers. So I already know these numbers by heart, so I'm going to go ahead and put them in. So for the spindle speed, I'm going to leave it at 16,500 RPMs, And then for this surface speed, that's not really listed in the Othermill sets here. So some of them aren't listed, but that's okay. I just leave them by default, and that seems to work fine. So the next thing I'm going to change is what is listed is cutting feed rate. So I'm going to change it to 1500 millimeters a minute. And then the last thing rather is the plunge rate, and I'm going to change it to 381 millimeters a minute. And that's basically all I want to change. Next thing I'm going to do is I'm going to go to geometry in this tab here. So there's a bunch of tabs. We'll work our way through it. So the next one is geometry. What do you want to cut, right? What on your model do you want to cut? I want to cut out this geometry here. So that's what I'm going to do. I click on that. That selects it as a chain, so that's good. And the next thing I'm going to do is I'm going to click on passes. And what I'm going to do is I'm going to turn off stock to leave. This is like how much stock do you want to leave. I don't want to leave anything. I just want to cut it as close to as I can get it. But the thing I do want is I want multiple depths. So I'm going to turn that on. Multiple depths will make it so that it's less aggressive on our tool and doesn't break the bit. So since it is a thin bit and it's not really thick, I want to do multiple passes stepping down so that the milling can cut a little bit at a time and then just keep layering itself out. So it's kind of like layer height for 3D printing. So I'm going to put 0.4 millimeters. That seems to be a pretty good step down. Now if you look in Othermill, they say the max pass depth is 0.02 millimeters, and that's really conservative. I've found though a 0.4 is pretty good. It's pretty good in mine. I've done quite a few projects with acrylic now, and I think that's a pretty safe bet there. And then that's pretty much it. I'm gonna hit OK. Then the next thing that's gonna happen is you're gonna get these blue tool paths. These are a lot like it's G-code tool paths. So you can see how many times it's gonna step down just by looking at this right here. So there's 1, 2, 3, 4, 5, 6 lines, and they're kind of different once you go down here. It gets a little bit smaller because of the actual depth of the model itself. And then you see some of this red stuff here. This red stuff is a spiral ramping, so this is kind of like winding itself up. It doesn't need to be that big, but for now it's fine. In a later episode, I'll show you how to actually minimize the time so you can get a faster cutting job. So let's take a look at our simulate. So if you go up here and you click on simulate, this will actually play. You have like a set of play controls, media controls, and you can see what it's actually going to do. So you see it's like winding up. It's just cutting air right now. And a better way to see this is actually to turn this tab on here where it says stock. If I turn that on, then it renders it does its best job to render out how our material will actually be cut out. So what I'll do next is I'll hide our object, and then I can play through this and see what it's actually going to do. Now it's kind of slow in my computer because I'm doing a tutorial. I'm like recording it, and I have all the apps open. So you'll see here that it's pretty sluggish, but it's pretty slow for most part. There, it's starting to speed up a little bit better. So you can speed through this. You can see you can speed through it here using these speed controls. Or if you want to see at the very end, click on this one, go to end of toolpath, and you'll see what it does. So this is what it's going to cut out. So that looks pretty good. And if I turn on my object again, you can see that it's pretty close to it, right? So it's pretty close to it. It's not leaving any stock. The tolerances are set to like 0.01 of a millimeter, which is pretty accurate. All right, so that looks pretty good. So the next thing I want to do is actually want to cut out the outline of the whole thing so I can pop it out of the bigger stock of acrylic. So to do that, I'm going to use something called a contour. So to add to this setup, I'm going to click on 2D, and then I'll click on 2D contour, and that basically just does a one contour shape. So again, I'll actually our 132-bit or 132 end mill is already selected, but I want to change it for a bigger tool. So I'm going to come down here all the way down and click on the 1/8 inch. This is like a really thick tool. You can see there's our 132, and then our 1/8 is like massive. It's gigantic. So this will cut through the material very nicely. I'm going to do the same speeds. The cutting rate, I'll change it to 1500, and then our plunge rate to 381. And if you look on Othermill's website, it's pretty much the same. Next thing is geometry, right? Just like we did with the the pocket, we're actually going to pick the bottom of our outline, the farthest outline that we have here. So we have that selected now. It turns blue. And then for passes, we want to do the same thing. We want to turn on multiple depths, and we want to change this to 0.4 millimeters, just to be a little bit on the safe side. That's pretty much it there. So hit OK, and then Fusion will generate those tools. And you can see how many times it's going to step down with that tool. 1, 2, 3, 4, 5, 6, 7 times it's going to step down. So that's cool. So now if we click on the setup, we click on simulate, and then turn on stock, we can go all the way to the end of the toolpath and see what it's going to look like in the Othermill. So you can see it's going to cut away all this material here, all this pocket area, and then it'll cut out with the big end mill the actual outline of our Pokemon logo, Pokeball logo. And then you can see it actually is going to cut a little bit away from our stock. So that's just sort of what it needs to do in order to do its toolpath. So that's looking pretty good. And at this point, we're kind of done. But one last thing I want to do is I actually want to add a chamfer to the edge of these two circle things, these two objects here. I want to add a chamfer because right now it's actually a little bit sharp. And what the chamfer will do was make a really nice edge here. So right now it's actually kind of sharp. See that? It looks pretty, but I kind of want to add that chamfer here so that it doesn't get caught in my pocket or doesn't cut me, because it's pretty sharp, right? So I'm going to add that chamfer. To do that, I need a special drill bit. We've been using flat end mills so far, and that's a very specific type of tool. But if we go over here in Fusion, we'll set up a chamfer, a 2D chamfer. So if you click on 2D and you go all the way down here, click on chamfer, and we'll click on the tool, select the tool. So there's only one chamfer tool that's available in our Othermill library, and that's called the chamfer mill. It's the 80-degree engraving bit. So this can actually do two things. It can be used as a chamfer tool to create chamfers, and it can be used as an engraving bit to do really fine engraving details. And you can see the tip is at a 80-degree angle. So that's what the tool is for. So I'm going to hit OK because that's the tool I want. And for coolant, for some reason it's turned on flood. We're just going to disable that. The Othermill doesn't do coolant. That's for like big machines that need to like spray coolant so that the tool doesn't break or whatever. So I'm going to leave the same spindle speed, but I'm going to change the cutting rate to 1500, and then plunge rate is 381. So that's pretty much the same we've been using throughout all three processes. Next thing is geometry. So what do I want to chamfer? I want to chamfer this, and this one here. That's what I want to chamfer. Next thing I'm going to do is I'm going to go to passes, and you'll see that the chamfer, how big do you want the chamfer? I actually want it to be 0.5, which is half of a millimeter, and the tip offset. So I've been looking at some different tutorials, mainly from NYC CNC, I believe is the YouTube channel. And the tip offset is you don't actually want to have it on the tip because you'll have like problems. So I'm going to put 0.5, which is the same as the width, and we'll see what it looks like here in a second. That's pretty much it for our setting up our chamfer. We selected our geometries, our edges, and we've set our speeds. So now I'm going to hit OK. So you see what it does here. So I'm going to click on simulate, and actually hit close. I want to click on this guy here, the full setup, and then simulate that, because otherwise I could just simulate each thing at a time. So now I'm going to turn on stock, and if you look down at our little scrubby timeline, you can actually scrub through this and click and drag, and you'll see when it changes, and it'll actually change different colors. So the blue one is the 1/8 bit, and then this color here, let me hide the object, the 3D model. So this is where it's going to start. Whoops. Hide that. Let me go over here and then click on play. So see what it's going to do. So there's our 1/8, and then it's slowly going to chug away, and you'll see that it's using the edge. So let me stop it there and then show you more or less what it's doing here. So you can see the tip of the bit is actually cutting away. So let me make it go slow. It's actually cutting away with the edge of the bit and leaving behind this really nice chamfer. So I'll stop it now because it's super slow, and then I'll go to the end of the toolpath, and then you can get a better look of what our piece is going to look like. So this is it. This is pretty much what we're going to get. It looks really clean. There's no tool collisions. Tool collisions is these little red notches that show up here. If everything is green, then that means you're pretty much good. That means you won't collide with anything. Your tool most likely won't break. Fingers crossed. So that's about it. I'm going to hit close now and bring back the object here. And that's pretty much it. What I'll do now is I'll export these out. So to export these out, you actually have to export them out individually. Since we're using different tools, we want to export these out per tool. So this is a 132. This is for the 1/8, and this is for the 80-degree engraving bit or the chamfer tool. So to export these out, you just click on them here in the setup, right click, and then go post process. And then you'll get the post process window. The only thing you need to change here is the post processor. There's a ton of them. And the one you want to select is the obvious one. It says Othermill. So Othermill here, generic for other plan. And then I'll hit OK. And then you get the window dialog to like save it out. So save it wherever you want. By default, it saves it here, but you can change it to your project folder. You don't want to name it .g code. You actually want to name it .cnc. So what I like to do is to name it something that I know. So like iPhone, and then Pokemon, or maybe just poke, and then I like to put the actual number bit, like, so in this case it's 132 inch, so I'm just putting dashes, so 1-32. So I'll save it like that. And then for the 1/8 one, I'll do kind of the same thing. Othermill's already selected for my post processor. I'll hit OK, and then I'll click on that to give me the same name, but I'll change this from 132 to 1/8.nc. I'll hit OK. And then for the chamfer, I'll right click, post process. This one's not a number, so I'll just call it like chamfer, I guess. So -poke -chamfer. That way you know what tool you need to use for which file. So now inside Other Plan, this is the software that comes with the Othermill. Depending on the Othermill Basic or the Othermill Pro, you're going to need the specific software for it. In my case, I have the Othermill Pro. It's basically the same thing, but it's just specific for that machine. So here's Other Plan. Now I'm going to set these up. I don't have it connected right now, so that's why it says tool unknown and I can't set it. But ideally you would want to set it and pick the material. So in this case it's 4 inches by 4 inches. So I'm just going to input that in, 4 inches by 4 inches, and then the thickness is 0.108 inches, because that's what it translates to in millimeters, the 2.75 millimeters. So that's how thick it is. And then I'll hit open files, and then I'll navigate to wherever I saved it. So I'll pick the first one I want to do is the 132. So I'll pick that. And it'll say tools, milling tools not selected, so just go to unknown and then click on 32, and then you'll get a render of what it looks like here. So this is what it'll look like in the actual Othermill. It's a little bit iffy to kind of rotate here. I'm using the right click and then left click to pan, right click to orbit, or you could use some of these things here like front view, bottom view. That's a good one. And then you can open another file to add in more things. So this is the 1/8, and I'll come in here and say 1/8, not ball end mill. It's something completely different. The 1/8 flat end mill, and then you can see that it cuts through the entire piece of the material. So that looks pretty much like what we saw in Fusion. So that's awesome. And then the next thing is to do the last one, which is the chamfer. So click on that. And then I'll select the chamfer tool. It's the 80-degree engraving tool. So select that. And then that just looks like the render that we want. So at this point, I can connect my Othermill, load in my stock, load it to the closest to I can square with the lower left of the spoiling board. And then I can start milling. So that's about it. This is, if you guys have any questions, of course, drop them in the comments below, and I will answer them. So that's pretty much it. And then the next one, we'll just talk a little bit more about settings and whatever else you guys want to know. This is of course my first time doing tutorials on this, but hopefully I'll be able to do more every Monday. Of course, check out the YouTube channel. I'll have it linked somewhere. I'm lagging at this point, but whatever. There you guys have it. I hope that helps anybody out who's getting started with the Othermill, Other Planner, and of course Autodesk Fusion 360. That's it for this one, guys. I will see you in the next one, but until then, happy milling. Bye, everybody.